Not only did Mars once have water covering much of its surface eons ago, it is still there, trapped in the form of ice underneath the Martian soil. That is the conclusion of a new study that indicates there may be layers of ice 300 feet thick in some place at areas of the red planet known as scarps, which are steep banks or slopes. These scarps have a blue-black hue, which scientists think may betray the presence of thick ice based on an examination of the data. It would be a tremendous find, as it would not only expand our understanding of Mars, but also provide new leads in the search for life and provide a potentially necessary resource for a manned mission to the planet. Scientists examined a total of 8 of these scarps. Scientists have long known that there is water somewhere on the planet, but have come up with numerous theories on where it all went. A statement from the American Association for the Advancement of Science follows below. Erosion on Mars is exposing deposits of water ice, starting at depths as shallow as 1 to 2 meters below the surface and extending 100 meters or more. The ice is a critical target for science and exploration. It affects modern geomorphology, is expected to preserve a record of climate history, influences the planet's habitability, and may be a potential resource for future exploration. Whilst water ice is known to be present in some locations on Mars, many questions remain about its layering, thickness, purity, and extent. Now, Colin Dundas and colleagues have pinpointed 8 locations, using the Mars Reconnaissance Orbiter MRO, where steep, pole-facing slopes created by erosion expose substantial quantities of subsurface ice. The fractures and steep angles indicate that the ice is cohesive and strong, the authors say. What's more, bands and variations in color suggest that the ice contains distinct layers, which could be used to understand changes in Mars' climate over time. The ice sheets themselves likely formed as snow accumulated over time. Since there are few craters on the surface at these sites, the authors propose that the ice was formed relatively recently. Images taken over the course of 3 Martian years reveal massive chunks of rock that fell from the ice as erosion occurred, leading the researchers to estimate that the ice is retreating a few millimeters each summer. Because the ice is only visible where surface soil has been removed, Dundas et al. Say it is likely that ice near the surface is even more extensive than detected in this study. The ice could be a useful source of water for future missions to Mars. The abstract from the paper follows below. Some locations on Mars are known to have water ice just below the surface, but how much has remained unclear. Dundas et al. Used data from 2 orbiting spacecraft to examine 8 locations where erosion has occurred. This revealed cliffs composed mostly of water ice, which is slowly sublimating as it is exposed to the atmosphere. The ice sheets extend from just below the surface to a depth of 100 meters or more and appear to contain distinct layers, which could preserve a record of Mars' past climate. They might even be a useful source of water for future human exploration of the red planet. Thick deposits cover broad regions of the Martian mid-latitudes, with this smooth mantle erosion in these regions creates scarps that expose the internal structure of the mantle. We investigated 8 of these locations and found that they expose deposits of water ice that can be greater than 100 meters thick, extending downward from depths as shallow as 1 to 2 meters below the surface. The scarps are actively retreating because of sublimation of the exposed water ice. The ice deposits likely originated as snowfall during Mars' high obliquity periods and have now compacted into massive, fractured, and layered ice. We expect the vertical structure of Martian ice-rich deposits to preserve a record of ice deposition and past climate. The following is a brief excerpt from Wikipedia on water on Mars. Almost all water on Mars today exists as ice, though it also exists in small quantities as vapor in the atmosphere and occasionally as low-volume liquid brines in shallow Martian soil. 56 The only place where water ice is visible at the surface is at the North Polar Ice Cap. 7 Abundant water ice is also present beneath the permanent carbon dioxide ice cap at the Martian South Pole and in the shallow subsurface at more temperate certain conditions. 89 More than 5 million cubic kilometers of ice have been identified at or near the surface of modern Mars, enough to cover the whole planet to a depth of 35 meters 115 feet. 10 Even more ice is likely to be locked away in the deep subsurface. 11 Some liquid water may occur transiently on the Martian surface today, but limited to traces of dissolved moisture from the atmosphere and thin films, which are challenging environments for life as we know it. 61213 No large standing bodies of liquid water exist, because the atmospheric pressure at the surface averages just 600 pascals 0.087 psi, about 0.6% of Earth's mean sea sea level pressure, and because the global average temperature is far too low 210 K-63 degrees Celsius -82 degrees Fahrenheit, leading to either rapid evaporation sublimation or rapid freezing. Before about 3.8 billion years ago, Mars may have had a denser atmosphere and higher surface temperatures, 1415, allowing vast amounts of liquid water on the surface, 16,171,819, possibly including a large ocean, 20,212,223, that may have covered 1/3 of the planet. 242526 Water has also apparently flowed across the surface for short periods at various intervals more recently in Mars history. 272829 On December 9, 2013, NASA reported that, based on evidence from the Curiosity rover studying Aeolus Palus, Gale crater contained an ancient freshwater lake that could have been a hospitable environment for microbial life.